So like I said, we have David Lindner. He's going to talk to us about some of the, security around the fingerprint reader on Android and iOS. So please welcome.
So, little did I know that Nickerson was going to be talking about people touching him wrong, but I guess this kind of fits right into my theme of the day, don't touch me that way. So first, who am I? David Lindner, been around the security community for a while. 15 years of consulting, it feels like 50 some days. Right? I do a lot of golfing, and I hack usually simultaneously. I'm really bad at golf. I work at Invisium. We do the typical web assessments, blah, 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 blah. I focus primarily on the mobile side, with my passion being more toward iOS. Don't know why. Maybe because I don't like Apple. I don't know. So this is what we think of our apps, right? They're frickin' castles. Unfortunately, this is what I think of your apps. And this is what they look like, right? And ever since the fingerprint crap came out, I was like, you got to be kidding me, man. They tried this on laptops and it failed, so why is it any different with mobile devices? Can someone tell me what this is? Well, yeah, where? Why does everyone say Fort Knox? Come on, guess again. Perfect, sold. So this is the gold vault in the basement, if you will, many floors down in the Federal Reserve Bank of New York. The reason I bring this up is because for years we've been trying to, secure our networks, and we see them kind of as this big bank vault. What's interesting about this big vault is it takes two people to close and open the door. You see the big wheels there. It's a big door that rotates. Unfortunately, the way I see mobile and what mobile has done for our security of our big bank vaults is instead of this massive door that takes two people to open and close, it's more like a wooden door or a screened-in porch. So that's kind of how I look at things, especially with the fingerprint crap, right? So I want to talk a little bit about that today. Obviously, disclaimer, don't do any of this shit if you don't have permission to. But I'm going to talk a little bit about the history. I'm going to focus on iOS, just because it's been out and around longer. I will talk a little of Android, but it's still a little new, and it's on Marshmallow and so on. So the history of Touch ID. So in 2012, Apple acquired Authentic, right? And then they released the iPhone 5S shortly after that. With iOS 7, which included this Touch ID integration, which was awesome at the time because it allowed us to much more quickly text and drive, right? But at the time, you couldn't use it in your APIs. Apple's really good about that. Hey, we have these awesome frickin' features, but you can't use them. And then 2 or 3 years later, they open them up to apps. So you could use fingerprint or passcode, blah, blah. They implemented what they call the Secure Enclave, which is actually very important for what I'm going to talk about a little bit further today. And like I said before, they weren't allowing you to use the Touch ID for anything other than the OS until iOS 8, which then added some things such as the Secure Enclave. So early on, there were quite a few fingerprint attacks. Obviously, it's vulnerable to all of the ones we're used to, right? You saw right away people were breaking it through printing and whatever else. Did anyone see the group of guys that when they were setting up the fingerprint ID, they just walked down the line and each one of them touched the Touch ID sensor once? That allowed all of them to successfully authenticate to the device. So what does that say? What's wrong here with the way Apple's done things? It's kind of a yes or no technology. You can't use it for authentication, folks. You don't know for sure who that person is. You just know someone has set up their fingerprint on that device, right? And I'll get into that a little bit further. So it was built into the iOS device, hardware-based, tied directly to the whatever chip is in the device that you're using. So you can't just replace one or the other. You got to replace them both because they're tied at the hardware level. And what iOS and Apple did is said, hey, we're going to make this, you have to set it up at the actual OS, right? You're not going to be able to do anything through the app as far as turning it on and off. And they wanted to fully control that. And that kind of gets back to my point of there's really no way to successfully authenticate who the person actually is. And there's two ways to do it. And I'm going to talk about both of those a little bit more in depth. Anyone here an iOS developer? Done anything with Touch ID? Wow, okay. So there's two ways to do it. Local authentication context, horrible name. And then user precedence, which uses ACLs and the keychain. So this is the typical code that I come across when I'm looking and reviewing iOS apps. Wow, that actually shows up okay. So it's using LA context. The first thing it does is, hey, can I actually evaluate this person using Touch ID, aka have they set it up at the OS level? That's a key, because if they haven't, obviously they can't use it. And then it evaluates the policy, gets a return value of success or an error, and then something else happens. Anyone see a problem in this yet? Anyone do any iOS hacking? Come on, raise your hands. No? All right, so the examples I'm going to show you are pretty much straight out of apps that I've looked at. And I'm going to show you how easy it is to, I guess, bypass that. So LA context is horrible. And I'll explain that a little bit further. But this actually is from code that I've looked at, changed the names for safety's sake. But it evaluates whether you can use Touch ID. It evaluates the policy, returns success, error, and then it passes it off to some other method, show local authentication result. And then something happens and you're authenticated, right? So can anyone really tell me why this is a problem? Come on. Man. Right, well, any fingerprint can unlock it, so you don't even know who it is, right? I can run things out of order in iOS. So what's to stop me as the bad person from taking your phone, getting access, and just running this method directly and skipping over all the other crap that says, hey, you need to show me your finger and touch me bad, right? So what does that look like? And I'm in Canada, so I'm not connected to the network, and I have a video because it just makes it easier. So what I have here, so I use iProxy to connect to my devices, especially when I'm talking to a group of security folks, because frankly, I don't like using a network. This allows me to communicate with the iOS device. So what you see on the right side was an actual device. It's a crappy fingerprint app that I wrote, but it allows me to communicate over USB. So I'll walk you through this real quick. Not it, I swear. All right, so what I did here is I'm using iProxy, and then I'm going to SSH into the device. And now I'm root, right? So yes, this is a jailbroken device, and don't give me that crap about, oh, you got to jailbreak it, blah, blah, blah. Because you know what? People do it. So Cycrypt. Anyone use Cycrypt? So Cycrypt is going to allow me to hook into this application that I have running on my live phone. And so I'm going to connect to the process, Touch ID testing. As you can see there in my slow typing. And now I'm connected. So I can hook into this app. So what I'm going to do first, I believe, is I'm going to show you how it would work from the device. So I will select the button. It says, hey, give me your fingerprint. And so I do, and I'm successfully authenticated, right? So what happens if I provide the wrong finger? You're going to see here it's going to be an error. Try again. You're not who you say you are, which you don't really know who I am anyway. And there was an error. Well, how can I bypass that? Well, I'll show you here with Cycrypt. So in Cycrypt, I can use Objective-C. I can use JavaScript to talk to this application. So what I'm doing here is basically I'm trying to figure out where I am in the app. So if you're doing some sort of black box or dynamic pen test, I need to know where I'm at so I can start talking to it and doing some cool stuff. So what I've done here is I've dumped the current recursive description. I'm going to look at a memory address for this UI view, as you can see here. Grab that memory address, and I'm just going to get the next responder. So those of you that know Objective-C know that that's going to be, I'm looking for the view controller that I want to talk with. Voila, cool. Now I have a view controller. So at this point, I need to know what methods are being run in that view controller. So there's a print methods thing here. It's really ugly. But as you can see, show local authentication result. Now it has 2 colons that you might not be able to see. What that tells me is there's 2 parameters that I need to pass into that method. Remember, I'm connected directly and hooked into this app. So I don't even have to use the hardware. So I'm going to try a couple of different things because unfortunately it doesn't tell me what types or anything like that I need to pass in. So I typically try true and false because usually that will work for certain things. But obviously that didn't work. It brought up an error message. So I'm going to try null for the second because null usually works for about anything. And look, oh wow, I'm successfully authenticated. So unfortunately, the fingerprint doesn't do any good. This code that was just running actually was from a 2-factor auth app. Okay, this app you could hook into your bank account, and when you go on online or whatever, you can say use my 2FA app. Sends a notification to the device, and they touted the Touch ID as the most secure one, right? So it says opens your 2FA app, use Touch ID, and it logs you right in. Well, unfortunately, they used LA context in this method. It was easily bypassable, and now I could connect to the 10 different banks that they had set up with that 2-factor app. So you can see where that can be a problem. So another example here that I also see, well, I'm not going to actually pass in the value of success and error, but I'm going to check them within my code and then do something. Does that make it any different? Not at all, right? We'll see that real quick here. Maybe. Doing this over your head is interesting, you know. By the way, forgive me, I came in from San Francisco at like 2 this morning, so. All right. So it's the same sort of thing here. I'm going to connect with iProxy, going to use Cycrypt, and auth number 2 is that where show success or show error. So again, they're trying to use this LA context to successfully authenticate the person, but it's easily bypassable. And unfortunately, there's a lot of apps that you're downloading and using today that use LA context. And really, there's not much protection there for you. So I would highly recommend not using it, unless they're doing it a different way, which we'll talk about. So I'm connecting again, and I'm going to show you how quickly and easily you can do it with this. So again, it works the same way. Prompt looks the same. The result's the same from the actual app, from the hardware itself. Right? So obviously that's failing. No good. Bad finger. Bad touch. So I'm going to use Cycrypt again, figure out where I'm at, and figure out if any of those methods look interesting to me, and then try to run those methods directly. So I went right to the actual UI view this time, got the view controller, going to look at the methods. So I know for auth number 2, the 2 methods that I'm interested in, because I wrote the crappy code, is show success and show error. So I'm going to go through the different methods here. You can see the selectors and so on, but show success. There's no parameters that need to be passed, nothing. So I'm just going to call that directly. Now that could be go to a different view. That could be a million different things in the app. But again, I'm going right around the fingerprint authentication. So I show the success, and now I'll show the error. So one other way that I've seen that people are using Touch ID incorrectly is they're like, haha, well, I'm not going to have an actual method that I'm going to create. I'm going to go against every development principle ever and just start using iOS APIs directly after I check success and error. Well, that just makes it a little bit more difficult, but obviously through IDA or Hopper or whatever you like to use, you'll be able to figure out in what order those things are happening and do it directly. So, LA context, evaluating the policy is crap, but in some cases you have to do it, right? So how do we do it? Well, you can define private methods, but unfortunately they're not really private. They still show up. Unfortunately, Objective-C is a static discovery language. So no matter what, you can discover method names and all that statically out of the box. But you could use dynamic method resolution. And that looks like this, right? So in Objective-C, we typically see some method declaration that looks similar to this, but instead, use this. That turns on dynamic method resolution, okay? So I'm going to show you the difference here, what this kind of looks like, using some different tools that I use. So there's a class dump tool that you can run against the API, or it's going to be the binary. So the IPA has a bunch of info in it, and there's a binary that's created. So I'm going to run class dump against my app. So class dump, this is a binary app, and I'm looking for show success. And it found it, right? So what I did, I was like, well, maybe I should turn on this dynamic method resolution. So I created another app that looks exactly the same, except for what I had just showed you, how to do the dynamic method resolution. And that's just Touch ID testing 2. And it's not there. So it's kind of hidden, right? Unfortunately, it's still security by obscurity, right? I mean, if you work hard enough, you'd still be able to figure it out, at runtime and things like that. But another tool I use a lot of is strings. Anyone use strings? Yeah. Same sort of thing. You can run strings against these iOS binaries and find what you're trying to grab. As you can see, show success shows up a couple of times. Strings is a little bit more difficult because it does dump a lot of crap and it takes a while to go through it. But if we do it on Touch ID testing app 2, there's nothing there, okay? So dynamic method resolution does work. So why is that? Well, it's basically C, right? I mean, it's hard to explain, but Swift has kind of gone this route, right? All of Swift is dynamically generated. So there's no real static discovery. So you might be saying, well, let's just use Swift. Well, you can, and I recommend it other than compiling because it takes forever. I don't know if you've written any Swift apps. But a pure Swift, the key there is pure Swift. You can't have the bridge turned on, the Objective-C bridge. It has to be a pure Swift application. It's compatible with the Objective-C runtime. You can run it all over the place, right? They're touting it now that they're going to run Swift on Android, which will be interesting. Runtime manipulation is limited. If you tell me, if you're a security tester and you come and say, yeah, I'm going to run Cycrypt on your Swift app, you need to be punched in the throat. I mean, seriously. Cycrypt does not work on a Swift application. You're not going to get anything out of it, and don't pretend like you are. It's very hard to analyze. The Class names, method names, it's all mangled. It's a mangled mess. But you can still do some hooking. So I'm going to show you, well, not show you, but in the slides I'll show you how that's done. So this is kind of what Swift looks like. You can run NM against that Swift binary, same thing that I showed you before, and it dumps a ton of crap. But basically it looks similar to this for methods and classes and things like that. You wouldn't necessarily know what that means, right? Other than the fact that __T means it's a Swift method, F is for function, and C is for class name. But it's actually pretty straightforward. So we have a Swift method, function, and class here, and then the next 8 characters are the name of the app. The next 14 characters are the name of the actual class. This S might screw people up. It's not view controllers is the name of the class. S means it's a selector method, okay? And then you could change that to, a setter method. You could change that to a G for a getter method. And then the next 11 characters is the actual method name, user success, and then the return type. That capital S says the next character is going to tell you what the return type is, which is a Boolean. So from there, you can run that against Swift demangle, and it will actually make it printable and readable and say, oh, okay, that makes a whole lot more sense to me. It's the setter for user success, and it's a Boolean. Make sense? So how do we hook into that? Very easily using mobile substrate. So the hard part is getting past all of this and trying to figure out which method is important. So whatever fingerprint method is happening after that LA context evaluate is the one you're going to want to try and figure out and find. But it's very straightforward to set up a hook. So I'm going to create my own set success. I'm going to use the old user success, and I'm going to set that to true. So any time this method, this ugly, mangled method is called in the app, it's always going to return true. So it doesn't matter if that fingerprint succeeds or not. So while you can't use Cycrypt, and you'll say, well, I'm just going to use Swift, it's protected. No, it's not protected. You can still use mobile substrate to hook. It's just going to take someone longer. And there's tons and tons of info on hooking. That's a whole other talk, but a couple different resources here. And then strings in Swift, same sort of thing. You can run it against, so I downloaded just some stupid app that's using Touch ID and Swift, and I ran Swift ID against it and got back info. So you can still run strings against Swift. So really, when it comes to LA context and using it for the actual evaluation of the policy, don't do it. Unfortunately, for many reasons, I wouldn't use Touch ID at all, specifically because you don't know who's actually touching and authenticating, if you will. But it's really no better than any local PIN crappy implementations that we've seen before. It reminds me of all those, save your photos locally, they're going to be protected by a 4-digit PIN. No, they're not. They're not encrypted, they're not doing any of that. It's just a view controller that you bypass, right? So how should you use the APIs? Well, you should use it with Touch ID and Keychain or user presence. I'm not sure why they call it user presence because they don't really know who the user is, right? They just know someone's present. But this was first implemented in iOS 8, and unfortunately it took them till 9 to have a few more accessibility options, and I'll walk through those. It does use a secure enclave for storage, so that's not directly accessible programmatically, that is. So you can't just go and grab all the keychain items willy-nilly like you used to in the past. So this is directly from Apple's documentation, but this is kind of the flow, right? Here you have user land, you have your application running, you're using security framework, and sec item is kind of how you add, update, remove items from the keychain. And that is actually communicating to the security D daemon, which handles everything, right? And it actually has then keychain pointers, which then are pointing to something in the secure enclave, whether it's secrets, passwords, anything like that. So that's basically how the keychain works. So what does it look like with Touch ID? It's a little bit more complex. Okay, so you still have your user space. You don't interact with the keychain really any differently. It's just a different attribute that you tell it to use Touch ID. And unfortunately, they, again, call it local authentication. But that's done at the operating system level, right? So all of the Touch ID stuff is actually performed within the secure enclave. So the actual authentication of the fingerprint itself is actually secure. It's just the LA context after the fact is not. And then this has credential management, key management, and again, that in and of itself is its own talk. So what's it look like in iOS 8? There's only one option. They either use it, Touch ID, or they don't, okay? Unfortunately, that's not very strong because what happens if someone gets a hold of it, adds a new fingerprint, removes some fingerprints, you just don't know, right? Because there's no way to tie that authentication to a specific user. But it's very easy to set up. You create a sec access control reference object, and the one attribute that's important here, again, is the ksec access control user presence. And that's in iOS 8, and that will basically say anything that you're storing in the keychain with that attribute, the only way to retrieve that is by successfully authenticating to Touch ID, okay? Or saying that fingerprint, we know what it is. In iOS 9, they added some more options, which is pretty good, right? So they added the ability to do kind of a fallback to an application password. So you can set a password for the application itself if Touch ID isn't working. You could fall back to the device passcode. So for some reason, I mean, user's been in the pool all day. You know how that is. Your fingerprints get a little mangled. You can use private keys. And these are the two that are interesting. So when it's set up, so when you save something to the keychain, usually it's a username and password. When you set it up, if you say Touch ID any, that means as long as that fingerprint is registered at the iOS level, they're authenticated to that data and that data is returned. But if you say Touch ID current set, if anything changes from the time that that data is first set in the keychain to the time when it's retrieved, so a fingerprint's added, a fingerprint's removed, now fingerprint won't work because if it's changed. So it has to be the current set when that data is set in the keychain. So the application password, I'm still not sure about this one, so mind you, but it's very straightforward to use. See, what's interesting is this LA context. It's used for the actual policy, which is fine. Use it for the policy. Just don't use it to evaluate the policy, if that makes sense. But when you try to get that data from the keychain, if the fingerprint fails, you can fall back to this app password. The only key here is where are you going to store or have any info on this password that the user is going to provide, right? That's the piece that's a little iffy right now. So iOS 9 looks very similar to iOS 8 as far as how you set it up. The only difference here, as you can see with the attributes, I have an or. So basically use the current set or fall back to the application password, which there was nothing like that with iOS 8. So what's that look like using that, which most of your banks and so on are probably doing it the appropriate way. I say probably because I don't know for sure. But so this is Touch ID using the keychain. Okay, so I'm going to save some value to the keychain. Test. Now, you can have it where when you save it to the keychain, they have to use their fingerprint to do that too, but you don't have to. But now if I want to get it from the keychain, it's prompting me for my Touch ID. There's no other way to get that data. I can't bypass it. Remember, Touch ID, it's all happening on the secure enclave. So I can't get the data from the keychain without successfully passing that Touch ID. So I can't use Cycrypt to bypass it. I can't use keychain dumper, so there's ways to dump the keychain. It will still prompt me for that Touch ID. So if you are using Touch ID, use it this way. Save something important, whether it's username and password, some long-lived session token, however you want to create your apps. But don't ever use the LA context evaluate. And that's what I just said. Cool. And that went really fast, because you guys are quiet. So in reality, I mean, to talk differences with Android a little bit, so anyone here doing Android Marshmallow Fingerprint APIs? Samsung, anything like that? So Marshmallow is the first officially supported API for fingerprints through Google. Samsung had their own for a while. They actually still do. So if you want to support Samsung phones, you have to use both Google's implementation and Samsung's implementation, hence one of the problems with Android. But Android actually will allow you to set fingerprints through your application. So at that point, you have some semblance of authentication, if you will, because it's not tied to the OS level, at the OS level. It is saved in their trusted execution environment, kind of like the secure enclave, but it's all done through your actual application. Unfortunately, where Google screwed up is they still have the ability, like LA Context, to only do local authentication without storing something in the trusted execution environment. And they put it up to the OEMs, the manufacturers of the devices themselves, to manage all that at the hardware level. So there's just so many problems from an Android perspective. I tend to stay away from recommending people use any of these fingerprint APIs. Like I said, we had them on laptops and they failed. So why are we putting them on smaller laptops for our authentication, right? So fingerprint security is hard. Try harder, aka don't use it. Questions, comments? I went through that really fast. You guys are still sleeping. You must have went out and got drunk last night. I wish I could have. I was flying in from San Francisco. Yeah. Yes. So keychain dumper is just a binary you put on the phone itself. So there's a couple of ways to still get at that keychain info. Backups will still have some of that, but it's all encrypted somehow, right? I mean, there's pointers and keys and all that. But with keychain dumper, if you run it locally on the device, so again, you're rooted, you run it against the keychain, right? Which uses security D and all that. It has to go through that same process that I kind of showed you before. But it will prompt you. So if any of those entries in the keychain have used the fingerprint to save, it will prompt you for the fingerprint, and it won't return anything unless you pass that. Anyone else? All right, cool. Thanks, guys.
Thank you, David.